Right. So now you've shown how to use simple linear regression with SSPs to do function learning and how the choice of inductive bias can affect your ability to learn that function. But what about continuous maps? What if we wanted to understand where there are discrete objects deployed in a space instead of trying to learn a continuous function over a space? Well, we can simply bind the SSP location of an object with that object itself, and thus we create a continuous slot for a discrete object to fill. We can construct maps by taking all of the objects bound with their respective coordinates and then bundle them all up into one vector. We can then query that bundle to see where objects are, or we can query points in space and see what objects are at that location. Here we have a map with a circle, square, and a triangle distributed about the space. We bind these shapes with their coordinates and we make a map. And when we query that map for the circle, we can see that there's a hotspot located here at the coordinate of the circle. This is also true for the square and for the triangle. But if we query for a hexagon and there's no hexagon on the map, then we see that we basically get no similarity across the space. Turning this on its head, we can query for coordinates and ask what's located at a specific point in space. Say we pick 0 and -2, we get back that a circle is the strongest responding object at that location. And similarly, again, for a square and triangle. But when we query for something at the origin, we see that there's no response, or a very weak response across the board. So let's experiment with maps now.